For maximum picture quality, it may be necessary to adjust the tracking control on your VCR.
Soaring on the wings of astronauts, we have become a space-faring race. We have marveled at the technology that makes these voyages possible. But what really fascinates us is the human perspective from space. We set out to explore new worlds, and then look back to an even more startling sight. On the way into space, we discovered the Earth. Just a few hundred people have actually witnessed this sight. But through their pictures, all of us have experienced the enchanting beauty of our island in space. Astronaut Kathy Sullivan.
We bring back images that show you and me and my parents and our families what the Earth would look like to you, to us, to them. Landsat, weather satellites show us things we recognize the shapes of and we appreciate the importance of in terms of warnings and so forth. But it doesn't somehow seem to connect in the same way that the picture out the window taken by someone just like me connects.
Through the astronaut's eyes, we have also recognized that our planet is fragile. The delicate blue line on the horizon is the atmosphere that keeps everything on Earth alive. Colonel Charlie Bolden.
When you look out and you look across our atmosphere, and it looks like the skin of an onion, not an orange peel. At one time, I had heard it described to me as if it were the peel of an orange. That's thick. Our atmosphere is like the skin of an onion. And you can actually see some of the pollution at times where it's not nice and clean and bluish, but kind of a cruddy brown. You can look down and you can watch the silt run off the island of Madagascar or silt coming out of a lot of the rivers along the Gulf Coast of the United States. And you realize that, hey, we're really taking a little bit of this thing that God has given us and we're throwing it away.
Now, through the eyes of the astronauts, the Earth, as humans have always dreamed of seeing it. The dream of seeing the Earth from on high was first realized less than 150 years ago. a daring pioneer takes a primitive camera over the rooftops of Paris and captures the first aerial photograph. At the turn of the century, a kite allows the camera to soar even higher, just in time to record the devastation of San Francisco. No technique for putting wings on the camera goes untried, even if it means wings in the picture. But a new era opens up with the ingenuity of the Wright brothers. And for the first time, a motion picture camera goes on an airplane ride. Just 40 years later, airplanes are left behind by rockets. The V-2 is born as a weapon. But in 1947, the U.S. Army assigns some of these captured German rockets to science. One is immediately fitted with a camera and sent up to capture a sight we'd never seen before.
Ignition.
The takeoff is smooth. And through these films photographed from an American rocket in flight, we are away on an amazing armchair journey into space. The New Mexico desert slips away below. The Rio Grande Valley and the mountains of the Continental Divide pass by like whistle stops. Up and up the rocket flashes, traveling at a speed which, for security reasons, must remain secret. The motion picture camera gives us a spectacular glimpse of the planet upon which we live, from a height so great that the Earth's curvature is plainly visible. Tipping and spinning, the rocket loses momentum. Now it has reached its summit, 76 miles up, the highest distance from which the Earth has ever been photographed. The rocket starts its dizzy descent, pointing at the sun one minute, the Earth the next. The camera sweeps across the horizon, recording on film an unprecedented view of the lower part of a North American continent.
Just 15 years later, the USSR and the US are ready to put men aboard the rockets. The image of the Earth from space is at last revealed to the human eye, thanks to the courage of astronauts like John Glenn.
Plasma grade's fired. Okay. Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous.
Back in those days, we were trying to find out in orbit and in the weightlessness of space flight just what happened to the human body. And as far as looking out at things or taking pictures of things, we didn't know whether the human eye even would change shape in extended hours of weightlessness. And there were some doctors that thought your eye might get myopic or change shape some way and your vision would be affected. And in my little Friendship 7 spacecraft that's over in the Smithsonian, you'll see on that a little eye chart on the panel where I was to read that at about 20-minute intervals during the flight and see if my eyes were changing shape, my vision was changing. But the camera, of course, wouldn't change shape. We knew that, so the camera was going to record some of this anyway, whatever happened to the human eye.
So the Friendship 7 spacecraft was equipped with an automatic camera. But John Glenn was so enamored with the view of Earth that he also took these snapshots using a camera he'd bought in a Cocoa Beach drugstore. The cameras flown by astronauts soon became more sophisticated, and the distance they traveled grew greater every year.
Hey, you look pretty nice over there, Yankee. Listen, Clipper, I'll turn on my tracking light for a minute, see if you see it. Okay, beautiful. We can see you coming down the ladder right now. It looks like you're on the bottom step. And on the surface. Hippity hoppity, hippity hoppity, hippity hopping over hill and dale.
But again, even from the moon, the most mesmerizing image we saw was the Earth, rising from the black void of space. And while astronauts treated us to this breathtaking extension of the human perspective, satellites began to collect revealing views of an entirely different kind. New York City and Long Island is seen by Landsat. Land use determines color in these images. The rectangle of Central Park stands out clearly. Urban areas are gray-green. Chicago sprawls alongside Lake Michigan, while San Francisco and Oakland face each other across the bay. The black of ocean depths outlines the unmistakable shape of Cape Cod. And this stunning peacock is the big island of Hawaii, from the hot blue tip of Mauna Loa to the red band of sugarcane on the northeast coast. In sharp relief, the ribbed contours of the Appalachian Mountains in Virginia. Satellites help us learn how the land was formed and how the oceans work. Hot colors are used to dramatize high surface temperatures in the Gulf Stream waters that swirl around Florida. Satellite pictures also show us how we are changing the land. The circles and squares of irrigated fields turn the high plains of Texas into a mosaic. These are the cattle grazing lands of Alberta. Just across the border in Montana, farmers alternate strips of cultivated and fallow fields. Different ways of using the land make a political border visible from space. And satellites can even track the spread of people. The area around Dulles Airport in 1982 and in 1989, the telltale gray of urban growth is eating up the countryside. Today is the era of the space shuttle. A whole new habitat for humans in space. But one goal of spaceflight hasn't changed. On every shuttle mission, the astronauts take thousands of photographs of the Earth. While satellites fly fixed routes and focus on predetermined targets, humans can capture unpredictable events, like the sudden fury of a tropical hurricane. Oil spills in the Persian Gulf. Even a remote volcano in eruption, spotted for the first time from space. To get the most from these observations of Earth, the shuttle carries a formidable array of cameras.
The 70-millimeter camera that we use for mostly Earth observations is a Hasselblad. It's a standard Hasselblad that's pretty much not modified for our use. Has a motor drive on it.
This is a standard 35-millimeter camera that most folks have at home.
We have been evaluating off-the-shelf camcorders. We found these very useful for in-cabin photography and for experimental documentation.
We've got here is a 16-millimeter Aeroflex motion picture camera.
This is actually an identical camera to a camera that's used widely in the motion picture industry.
I'm going to downlink first what we call camera B. The payload bay is a rectangle, and at each corner there is a camera. Going back over to camera A, you can see the remote manipulator system off to your right, and it also has 2 camera systems on it.
But science isn't the only or even the main purpose of shuttle photography. The astronauts are also tourists. They carry cameras to bring back to the rest of us the experience of seeing the Earth from space.
As anyone who goes on any trip, vacation with a family or anything, it's only fun if you can talk about it and share it with people when you come back. There's a certain sense of satisfaction in just having gone, but there's so much good feeling if you can share it with people. And the only way that we have to do that, since we can't get around and talk to everybody in the United States or in the world, is to take photographs that subsequently get passed around.
Some of the most powerful pictures to share the astronauts' experience are part of this movie. Around the world, in IMAX theaters like this, millions of people have seen The Dream is Alive. This unique movie system fills a huge screen with images 10 times the size of a conventional feature film. The Dream is Alive is the closest we've ever come to living and working with the astronauts aboard the space shuttle. And now the astronauts are filming the Earth for the latest IMAX space movie called Blue Planet. To translate the vantage point of the space shuttle to IMAX film, they have to master the intricacies of the world's largest camera.
Got it coming out the overhead window. It's going to be beautiful.
Okay, all ready.
And back on the ground in Houston, producer Graham Ferguson has to plan every film shot carefully. The shuttle carries only a small supply of the heavy IMAX film.
And while we've got you, IMAX thinks you may have a good film opportunity crossing the U.S. to look up the West Coast, the Gulf Coast, and the East Coast.
Yeah, you bet. We thought of that when we were describing it to you last time, and I think we're going to try to do that. Charlie says that we've already got the film loaded and ready to go.
Thanks.
Kathy Sullivan raises the enormous camera to the shuttle's overhead windows. And she sees the entire west coast of the United States. The Bay Area is passing by at the bottom of the screen. Down the center stretches the green San Joaquin Valley. The snow-covered mountains on the left are the Sierra Nevada Range, and the cloud bank on the right follows the Pacific coast to Los Angeles and beyond. Now the shuttle flies over the Gulf of Mexico, with New Orleans near the lower center of the screen. On the left, the coast of Texas disappears beneath the cloud cover. And to the north, a thin line of clouds follows the Mississippi River. Soon the astronauts look straight down on southern Florida, crossing Lake Okeechobee and the string of cities along the Atlantic coast from West Palm Beach to Miami. Inland, the Everglades run south to the Florida Keys. Now the shuttle flies over the Caribbean, leaving behind the Florida Peninsula and the western tip of Cuba on the upper left. And at 17,000 miles an hour, the shuttle races further east.
If Madagascar's looking good on orbit 46, if that looks good to you, it's always your discretion. It is a good target of opportunity.
Okay, so we got 30 seconds.
But Graham Ferguson is worried about the weather.
The clouds will build up there.
Should he try to film Madagascar now or hope for better weather on the next pass? He's got just 15 minutes to decide.
Go ahead, Charlie.
Okay, we did get the Madagascar pass. We think Bruce got from the west coast all the way to the east coast. There was a little bit of haze down there, but we were getting, it looked pretty good.
All too soon, the shuttle flight is over. And like all photographers, the astronauts are eager to get a look at their pictures.
That's right there.
But to see these pictures, they have to come to an IMAX theater.
Look, the Vale of Kashmir, just like you always read about it, that is spectacular. And all the lakes. All right.
Where is this guy?
I think this is, well,
I'm having a hard time.
Look at how,
There's a
now I
coast.
see, I can only, now,
This is not the Texas storm, but I can't tell where that coast
but
is.
see, I haven't been able to envision what
It's
Bill
in
was
my,
saying.
I think I wrote it down, and we gotta go
We
back
have
and
it
look at our
logged.
notes.
We have it logged.
I can't remember what it is.
Look at that.
See, it
How
was right
smooth
back on
that
there.
is.
Just left it on the side.
Oh, shot.
It worked,
Now,
Charlie.
what would you
It worked.
guys do? Would you feed in?
For the astronauts, it's almost like being back up in space aboard the shuttle. And now it's your turn. You are about to blast off on your own shuttle flight. You'll make one sensational orbit of the Earth. You'll see the finest of the films shot by the astronauts, including spectacular views from the IMAX movie Blue Planet. Charlie Bolden, Kathy Sullivan, and fellow astronaut John Blaha will be your guides on this unprecedented tour. Your rocket is on the pad. The countdown has begun. But first, your local public television station wants to ask for your support. Don't go away. It's T-minus just a few minutes and counting.
It's T-minus a very few minutes. We're only going to be here for just a couple of minutes. I'm Carol Moore, live in the studios of Vermont ETV with Jim Reed and our volunteers from UVM's Alpha Gamma Rho fraternity, giving themselves a nice hand and welcoming you to our evening of spectacular aerial photography. We're doing the astronaut's view of the Earth, and then we'll go to Over New England. So whatever you do, stay tuned. I'm holding, of course, the Over New England video cassette. That's our special thank you gift to you if you pledge in support of magnificent photography at the level of $60. Our volunteers are standing by. They'd love to talk to you. And after Jim and I have talked to you for a couple minutes, we'll go back to the rest of the astronaut's view of Earth. Those of us who can remember way back to when John Glenn first circled the Earth. It's so awesome to see what they're doing now, what they're photographing. And that picture of the tropical storm, I just think was one of the most beautiful things I've ever seen. I can't wait to see the rest of it. I hope you will. Give us a call, 655-1100.
Gee, Carol, you can remember that? Look up in the corner of your screen. You're not dreaming. We've actually got only a little less than 40 seconds before we go back to this beautiful view of the astronauts. And of course, a little later this evening, and not very later at all, over New England, we have here this VHS tape of the entire over New England, which covers every single state by airplane directly overhead for a pledge of $60. That's all there is to it. All you have to do is call in now, make a pledge in any amount. If you care to make it for $60 or more, ask for the Over New England tape. We'll be happy to give you that as a thank you gift. A wonderful evening of overhead views tonight. Remember, as always, TV worth watching is TV worth paying for.
Your support makes our programs possible. Thank you. Volunteers will remain by the phones during the upcoming program to take your call. If you prefer to pledge by mail, send your check to Vermont ETV in Colchester or Public Television Association of Quebec in Montreal. This is Vermont ETV.
We're about to lift off on a trip around the world aboard the Space Shuttle. Strap in and get ready for an astronaut's eye view of the Earth. In less than 2 minutes, we leave behind the blue band of the Earth's atmosphere and penetrate the black of space. Soon we'll reach our orbiting altitude, about 180 miles high. The shuttle always flies east, but there are windows all around the cabin. Out the window on our left stretches the east coast of the United States, from Long Island to Atlantic City and the long arm of the Chesapeake Peninsula. Looking south from this height, we can see the entire island of Cuba surrounded by coral reefs. The varying depths of the Caribbean show up clearly as shades of green and blue. Part of the Bahamas island chain. Soon we'll be over the open Atlantic Ocean. Astronaut John Blaha.
Our planet is predominantly water and clouds. If you stand back and look at our planet, most of the time from orbit, what you see is a big blue and white ball.
Even from 400 miles out in space, the oceans go from being deep blue, almost black, to the point where they start taking on colors of their own. And as you get into the areas where there are coral reefs and things like that, you can actually see the line, the land rising up out of the ocean until it becomes, boom, real land that, you know, terra firma, that people walk around on.
In 10 minutes, we cross the Atlantic to discover the Strait of Gibraltar. Europe is on the left, Africa on the right, and the Mediterranean Sea dead ahead.
The gates of the Mediterranean here by Gibraltar are one of my favorite sites. It's another one of those places where you find yourself mixing in historical recollections and seafaring recollections. You know, where did Columbus sail from? Who's sailed through those straits before? Wartime history and everything else.
Across the center of the screen, the English Channel that separates Britain from France and the continent of Europe. Under the clouds and haze, it's sometimes hard to follow the coastline. But but the boot and heel of Italy are like a map come to life. Further east, Greece and the Aegean Sea.
I grew up a sort of amateur, avid geographer, always poring over maps, always wondering about the world and studying different places. So I was sort of steeped in maps and geography from day one, and kind of fluently knew our ground track before I ever launched on my first flight. That was not true of all my crewmates, but I was very impressed to observe, on a couple of them in particular, just how eagerly and rapidly and sponge-like they sopped all this up within the first couple of revs around the world.
You look down, and although way out you can see a whole continent, while you're passing over it, you look down and you see a massive piece of land, and there are no lines, you know, and no colors like on the atlas or the globe or stuff, and you go, holy gee, what is that? I know what it ought to be, but it just doesn't, it all blends in together. But my first flight, I was lost all the time.
We're coming up here onto the Namib Desert in southwestern Africa. Those dunes may not look too terribly impressive in this scene, but they're actually hundreds to, in some cases, about 1,000 feet high. And again, you see signs of cold water offshore over which that dense, low-lying cloud has formed. This is the area that the 17th and 18th century sailors, 19th century sailors used to call the Skeleton Coast, and it becomes kind of easy to tell why when you see how desolate it looks.
This is one of my favorite views because you're looking at the Horn of Africa, the big chasm between Africa and Asia, where, you know, plate tectonics have caused one continent to separate away from the other. And it's most vivid in that particular region of the world, more so than any other place I can remember, where you get the feeling that you can actually see these two continents in real motion, real time, pulling away from each other.
The Middle East, the Nile River in Egypt, and the fork of the Red Sea that shapes the Sinai Peninsula.
In talking to kids, I say it's real important to study math and science, but it's also important to study history and to understand history. And in that very shot, you know, we have the history of mankind. And just about every kid, no matter what his religious background is, have heard about people like Moses. And, you know, you say, well, what do you know about Moses? And they say, well, I think that's the kid that, you know, his mother put him in the basket and put him out. And I said, okay, see that river right there? That's the very river. And if you follow up the river, if you go up it a little bit, you can actually see the V or the triangle of the Nile Delta because it's very green in comparison with the rest of the Sahara Desert around it. And I say, you know, I can't tell you exactly where it happened, but somewhere right around in there, you're looking at where that took place. And then I said, what else do you know about Moses? And they said, well, I think that's the guy that took a staff and did something and parted the water or something like that. And I said, and that happened right along in this area where the Red Sea flows up into the Suez, the Gulf of Suez. And, you know, you can look at it and you can see how, well, I think it's believable. And, but there's a lot of history just in that one shot.
This is the head of the Persian Gulf in the aftermath of the Desert Shield, Desert Storm campaigns, those great big black swaths that you see originating from at least 3 different regions. Something on the order of 600 or more wells burning in at least 3 different oil fields and streaming out in great palls of smoke.
The Kuwaiti oil fires just jump right out at you. When you see something ugly, it just jumps right out at you. I mean, I'm a technical guy and a flyer, and I've been that all my life. I never thought I would boost environment, but without a doubt, the Earth is very fragile, has a very fragile looking environment from space. We need to take care of that.
The Volga River meanders through central Russia as it runs down toward the Caspian Sea. We've already flown 8,000 miles, a third of the way around the world. Ahead of us, the endless steppes of eastern Russia and the deserts of Mongolia. But further south in India, Nepal, and Tibet rise the highest mountains in the world.
On STS-31, the Hubble Space Telescope mission, we did have an opportunity to see the Himalayas kind of up close. And that was very impressive. When you look from 400 miles down at these massive mountains, and it looks like, ooh, I hope I don't fall because I'm going to get really beat up. And it looks like the mountains are really reaching up to you, almost ready to grab the shuttle. They're so massive and so rough looking. When people try to climb Mount Everest, after looking down there, you go, I don't believe they did that, because it just doesn't look like it's conquerable.
Below the southern tip of India, by the Bay of Bengal, lies the island state of Sri Lanka. Soon we'll see north to China and the mouth of the Yangtze River.
If you look where the river mouths out to the ocean, just about the center of the frame, you can see it's choked with sediment for probably hundreds of miles upriver. And to the bottom and right of the scene, there's so much sediment dumped into the coastal zone that it almost can be difficult to tell where the land-water boundary is.
And sometimes it's even hard to distinguish the land from the sky, especially in the slanting red glow of a low sun. We've come more than halfway around the globe. Now we're approaching the land down under.
Along the northern and, the northwestern and the northeastern coast where people live, there are big inhabited areas that are quite evident to you from out in space. But most of the continent of Australia is barren. And you look at the deserts and you look at the little bodies of water and the mountains and everything. We call it the large boring landmass, but we say that in jest because it's pretty interesting to watch. Australia's deserts, which are massive, have their own identity because the earth there is very, very deep red. It's not red as we think of red like a fire truck, but the red of dirt. Much darker and redder than, say, Africa.
The colors are vivid in the afternoon sun, but ahead, the earth is disappearing into darkness.
One of the neatest things to do is to look at cloud features as you come up towards the terminator or the boundary between the day side and the night side of the Earth. We don't have normal days and nights on orbit because we're going around so quickly. We get a sunrise and a sunset every 45 minutes. And if you happen to be crossing through the tropics, as it appears we are here in this scene, you get tremendously nice, deep shadows that highlight all the topography of the clouds that are welling up through the tropical atmosphere. When you're on the space shuttle, you look down on the ground and you see the Terminator go by. You see the landscape go from light to dark. Everything beneath you is dark, and you're still in bright, shining sunlight. And you actually watch the sun set on the orbiter itself. You watch the tone of the light soften and become slightly more reddish-orange, and then with a speed that just amazes you, blink out.
At night, by the lights of our cities, we realize that people still cluster in coastal towns. This satellite composite photograph reveals the electric outline of the United States and the glare of the prosperous countries of Europe and Asia, from Britain and Germany on the left to Japan on the right. But in the global view, what stands out is the darkness of the entire southern hemisphere. And some of the light we do see is fire consuming the rainforest. In this view from the space shuttle, the moon seems to flare directly over Atlanta. This is the southeastern coast of the United States, turned almost upside down from the more familiar perspective of the map. That's Charleston, South Carolina, in the center of the picture, and almost the whole of Florida is outlined off to the left. The distinctive shape of Italy is easy to recognize even by night. From Milan at the top, the largest concentrations of light are the great cities. Next comes Florence, a bit inland. Then Rome on the western coast. and Naples just coming into view farther south. On the east, the dark waters of the Adriatic lap against the glow of smaller resort towns. But all the energy and the drama of the lights we have created pale in comparison to the lights of nature.
At night, the lightning seems to be doing its own choreography, and it's like you're listening to an orchestra or something. You can imagine the music that's playing as the lightning goes from cloud to cloud, and appears to go over hundreds of miles at a time. Quite a bit different from the way I perceived lightning before I flew in space, because I always thought lightning was a local phenomena. You know, it occurred right here over Clear Lake City and over one little section of it. When you look down on it from space, it appears to go over hundreds, if not thousands of miles, and it seems like one bolt of lightning seems to excite another one somewhere else, and so it travels all over the place.
It's not just the view that makes life aboard the shuttle unique. Everything is different in zero gravity.
Good morning, Discovery.
Even in orbit, there's the regular morning routine. But we have to learn how the experts do it in zero G. Listen in on an astronaut press conference.
We had to devise a number of exercise routines. And, of course, Marines aren't happy unless they do their push-ups every day. That wasn't too tough, so, you know, look, one arm. And if you want to, you can do put-ups. Now, not many of you can do this right here.
Then we hurry back to the windows, but there are no landmarks at all. The longest passage of our orbit is the endless expanse of the Pacific Ocean, capped by banks of clouds that sometimes span thousands of miles.
This is coming down along the coast where I grew up. Those are the Channel Islands offshore of Southern California. The fairly evident line that runs parallel to the coast across the frame is the trace of the San Andreas Fault, delineating sharp blocks of mountains from vast tracts of desert. And a little bright spot just about in the center now is the lake-bedded Edwards Air Force Base, where we often land space shuttles. This is one of my favorite regions of the world here. The body of water surrounded by land in the center is the Gulf of California, or Sea of Cortez. The Pacific Ocean is the blue water along the northern or upper side of the frame here. My father has been going to a place in Baja, California to go fishing once or twice a year since somewhere back when I was in high school, I think. Still likes to get down there, and I've been with him occasionally. So whenever I get a chance to get a good shot of one of his fishing areas, it's very important that I do that.
1,000 miles to the north, we can see the Great Salt Lake. Bear Lake, in the center of the picture, straddles Utah and southern Idaho. And on the left, the snow-covered ridges are the Wind River Range in Wyoming, a small part of the vast Rocky Mountains that cross the American West. Now we're over the Midwest, framed on the north by 3 of the Great Lakes. At the left, the tip of Lake Huron points to Lake Erie in the center, while Lake Ontario stretches away to the east. On the right of the picture, sun glint picks out the network of rivers in Tennessee. And in the distance, the Allegheny and Appalachian mountain ranges divide fertile farmland from Virginia and the coastal plain of North Carolina. We've completed a trip around the world. Now it's time to close the payload bay, take a bearing on Cape Canaveral, and get ready for re-entry.
Columbia, Houston, forecast winds remain unchanged. 240 at 16 gut 24. Those are within limits. You have a go for the burn.
Brian, on the lowest launch, or no for the first PBS? Oh, it's getting red outside. Yeah, sort of half a mile. Pretty out.
Look at that.
Beautiful.
Here we come.
I don't want to leave. I honestly do not want to leave. When I see that deorbit day coming, I'm actually sorry to see it come. And my wife and I have a very close relationship, but the first time that I returned from space, I literally said to her as we were hugging each other when I had climbed off the vehicle, she said, "I'm really glad to see you." And I said, "Brenda, I wish I were back up there in orbit."
Columbia, Houston, I see you on center line, on glide slope.
Roger, copy.
I wish we could share more readily, especially with younger people, that sense of the mystery and the fun and the drama of geography and the way that it ties together everything from natural history and natural science to human history and culture and language and everything that makes life on this planet. It's a delightful subject. Everybody is delighted when they get to experience geography from orbit, and I wish we could somehow inject that into the experience of geography in the classrooms and in homes on the Earth, so we would come to appreciate each other and know more about each other.
You're looking good. 250 knots, 240 knots, 230 knots, 220 knots, 210 knots, 200 knots.
I have seen a lot of evidence of potential destruction on the Earth, but basically the view that you get from outer space is that the Earth is one big, happy planet on which all of humankind live. And as far as we know, it's the only place in our universe where there is life, as far as we know. And the perspective that you get from space is that it is happy, and it is one, and that there are no dividing lines between people or between nations. And that's like I mentioned a long time ago, my first flight. You go, uh-oh, I'm lost. I don't know whether I'm in this country or that country. And that's because they all look basically the same. It all looks like one big happy Earth. And then you wonder, why can't it be that way? That it really ought to be able to be that way, except for mankind's selfishness and greed and things like that. Now that's idealistic thought, that's dreaming of the utopia. But people have got to dream and think that way, or we're never going to get there.
In the last hour, the astronauts and the people who fly with them have really shown us a lot of new ways to look at our world. Personally, I was struck by their sense of history as they look over the landscape of a particular part of the Earth and talk